right, so when we're thinking about different substances in chemistry class, we want to find a way to count how many atoms are there, or how many molecules, or how many formula units. So those are just different ways of saying, some substance. We have some number of atoms there, and we use them in specific cases. But if we're going to count atoms, which are really tiny, we need to group them together. We need to get a whole lot of them together and say, okay, we're gonna talk about this unit of atoms, and the unit that they've chosen is the mole. So there's a number you need to know, and it's called Avogadro's number. There's a little symbol for it, and it's 6.022 times 10 to the 23rd. So it's a huge number. You can't really understand that number. I can't understand that number. Maybe you can. But so they're small. We group atoms in moles to kind of make the units, the numbers that we're talking about, more relevant to us. 1 mole is Avogadro's number of anything. You could be talking about an atom, a molecule, a formula unit of some ionic compound. You could talk about anything, but it doesn't make sense if you talk about big things in terms of moles. The number's just too big. So I've got some different substances up here. We got water, which is very nice, very good for you, right? We've got sodium chloride, delicious. Can't have fries without salt. And then we've got sucrose here, which is only really used in the laboratory, or maybe if you have a birthday cake or a wedding cake to make. Special occasion. So what I've got up here is formula mass or formula weight. Okay, so this is something that you need to be able to calculate. If it's H2O, we just count the number of each type of atom. We've got 2 hydrogen atoms and 1 oxygen atom. And we look at the numbers on the periodic table, the average atomic masses from the periodic table. So that's hydrogens and that's oxygens. We multiply by the number of atoms, and then we add that all up and we get 18.02. This is the formula mass. And if we're talking about 1 water molecule, this would be 18.02 AMU, atomic mass units, because that's 1. Sodium chloride. This is simple because we have 1 and 1. We multiply by the masses on the periodic table, 22.99, 35.45. We add it up, we get 58.44. Okay, so if we have 1 unit of sodium chloride, 1 sodium ion and 1 chlorine ion, it's going to weigh 58 AMU. So we can already see some relative weights here. So formula mass or formula weight, you'll see this called. And for silver, we've got 12 atoms of carbon. For sucrose, we've got 12 atoms of carbon, 22 of hydrogen, and 11 of oxygen. We just might multiply those by their respective masses. We get 144, 22, 176. Add it all up and you get 342.30 AMU for 1 molecule. But we're not really talking about 1 molecule all the time. Most of the time we're talking about a mole of water, or a mole of sodium chloride, or a mole of sucrose, so that we can compare, well, how much does a mole of this weigh? How much does a mole of this weigh? And the nice thing about this is the atomic mass units, if we have a mole of it, we have that's 18.02 grams per mole. Same number. So 1 would be 18.02 AMU, but if we have a mole of it, it's 18.02 grams. So, and for sucrose, we have 342.30 grams per mole, and salt, we have 58.44 grams per mole. That's finding molar mass.